Hi everyone, this is Ritik from the Bio Protocol, and today I will be showing you the step-by-step process of setting up this plugin. So make sure you run these commands. So install the system dependencies, then clone the repo, run pnpm install, and then you need to run two Docker containers for this. So the first one is Postgres with support for pg vector. So make sure you run this command, and also you need to run oxygraph for setting up a triple store. This is only for local development, but if you plan to make a submission, you need to use origin trails dkg. So let me run this command first. So once you have this running, you can go to this URL, and this will open up your oxygraph front end. Kind of, this is where you can write queries and execute. So if I run this query, this is like the query for getting all the triples. So it says 0 results because there is nothing in our triple store yet, but we will be doing the processing and populating that. Now I already have this image locally, so I'll just run the containers. So this is so BioAgent says the Postgres, and PG admin is for like seeing the a way to see what is inside my database. It's like convenient. You can use any tool for that. You can use add miner, you can use pg admin, you can use anything. So before we start, I want to give you what are the different components inside of our plugin. So there is a Google Drive which has, so this will be our Google Drive which has all your scientific papers or scientific literature, anything. And as soon as you update this Google Drive, let's say you add a file or you delete a file, this Google Drive is connected to our database here. This database is also used by ELISA. So we have this particular table. So right now it's empty because this drive is also empty, but as we put in papers here, this will be updated. So how that is done is this is done using a webhook. So ELISA v2 has this really cool feature where you can define routes for your agents. So we have this particular route which the Google, we have to configure this, but you don't have to configure this manually. I have the plugin has a way to do this. Now once you update it, it will add a task to the task queue of ELISA. So all your tasks are stored in this table called tasks. So this is this table is managed by ELISA, and this is where all your tasks will get stored. So as soon as you add a PDF here, this table will get updated, and then your task will be executed. And so let's get started. So once you have your plugin, once you have the required container started, you need to do one more thing. You need to run ngrok. So this will set up like a tunnel for your local host, and it will give you like a URL which you can this is required because Google Drive cannot send notifications to this URL. It can only send notifications to a public URL like this. So this is like one thing that one thing that you need to take care of. But so for the sake of the hackathon, if you think that this is like an overkill, you can always not require the Google Drive integration, because this is like something that we made because so that it is easy for anyone using the plugin to set up. But but yeah, if you want to just watch a local folder inside of here, that is equally understandable. Anyways, so once you have the ngrok running, what you need to do is you need to just run the plugin. This will do all the setup for you. If you But you need to first have your environment variables populated, so that's important. So as soon as you put in a file over here, this the tasks table will get updated, the task queue of ELIZA will get updated, and it will fetch folders, fetch files from here and start the processing loop. So what's happening here is essentially that your PDFs are converted into RDF triples and stored inside oxygraph or origin trail DKG. Then also we have a hypothesis generator and an evaluator which will evaluate your hypotheses. First it will generate the hypotheses, then it will evaluate them based on a rubric that we have, and that is sent to a Discord channel of your choice. And the LLM providers that we're using are Anthropic and OpenAI, and the database that we're using is Postgres. So Postgres is used by ELIZA as well locally, so that is why we chose to use that. Okay, so it says no drive sync found, creating one, drive sync initiated, creating a watch channel. So it creates a watch channel. Watch channel is essentially what helps you monitor these changes that you make in your Google Drive. So now I will just go ahead and quickly upload a paper here, and let's wait for the Google Drive to send a notification to our agent. So yeah, it sent this notification. Now it says updated file metadata. Now if you go to file metadata, you will see that we have this updated here, and the tasks also got updated. So right now this is the metadata for the task. So the file ID is this one here, and we have the file name, we have the update interval, like how many the interval after which this should be updated again. So this is like a recurring tasks. All these are features used by ELIZA v2, so it's really handy. Now what we need to do is we just need to sit back and relax. This is like not a turn-based agent, this is like a 24/7 knowledge mining agent. And yeah, so the hypothesis generation is here, it's inside of this folder that is Anthropic. Yeah, generate hypotheses. So I have purposefully disabled this right now because for the sake of this demo I want to show things one by one. So the first part of this plugin is processing your papers and converting them to knowledge assets. The second part is generating the hypotheses and evaluating it. So that is done in a loop, like it's done every 1.5 minutes. So once this flow is completed, once our paper that we uploaded here is converted to an RDF triple, I will show you how the hypothesis generation works. So until then you can just relax, it won't take much long. Also we have like this is just something that we were testing. So we have a front end which shows us all the hypotheses that we have streamed or that we have generated. So these are all the hypotheses. So we processed a lot of longevity papers, and these are the hypotheses that we came up with. So if you click this, you can see the hypotheses. You can see the evaluation for it. I mean, this is just the summary of the hypotheses. Then this is the full hypothesis, like everything, and then you have the evaluation for it, which our judge LLM um, does on this hypothesis, and there is an explanation also for the hypotheses, and there is a score as well out of 100. So this is the score that it gave this particular hypothesis. So yeah, I mean, this is also something that you can build, a kind of a dashboard for the agent to visualize all the papers that it has processed, all the hypotheses that it has generated, their scores. Cool. So, and we need to wait a little more for this. So this will download the file, it will extract the DOI. Alright, so now the process has kicked in. It has got the response from unstructured. It will process all the paper. So what it is doing under the hood is that, like, a very general overview. We have already covered this in our tutorial with Eliza, that how this is being generated. So a very quick overview of it is that that video should be out, I guess, in the next week or so. But a very general overview is that we are using what we call as ontologies. So ontologies are formal systems for organizing knowledge. Think of them as structured dictionaries that define not just what the term means, but how they are related to each other. They are built on three components: classes or concepts, properties or relationships, and instances. So example, a gene is a biological entity, a protein is part of a cell. So let's say this term right here, this means has specified output. So that means that when you convert your scientific paper to a JSON LD, it will have this key OBI 0000299, and your paper has this specified output. So what that would look like is, so we have some papers here, processed papers here. So you can see that this particular key, it is saying that it has this particular specified output, that is that is this, and also this. So these ontologies serve as a way for like a machine readable way for your AI to traverse your knowledge graph and um, come up with something novel. So yeah, so it's successfully stored into oxygraph. Now let me show you what that looks like really quickly. So this is our oxygraph, and if I run this, yeah, so we have around 81 results now, and this is how it looks like. So these are all the triples. So the subject, predicate, object. Now if, let's say, if you want to get something specific out of your query, you can, I mean, this query just gets you all the triples, but if you want to say, let's say, if you want to get only the description part, okay, so if you want only the description, so I would say so I get this. Now if I want to get the description as well, I would need to write another and description. So description, yeah. So I get the paper and I get the ontology and I get a description for it. Now this is used for generating the hypotheses. So right now this query has given us this, but you can definitely make this query much more complicated to get a particular, let's say for a particular ontology you can get that particular description, and yeah, I mean you can use that to do anything that you like. So I mean, this is like a general way of how you can generate hypotheses, and now I will show you a way to I will show you that how the hypothesis generation on our plugin works. So for that I need to open up the BioAgents repo, which is right here. I will stop this. So actually the BioAgents repo is just like it's a full-fledged agent that can have multiple plugins, and the plugin BioAgent is just a single plugin. So that's the difference between these two repos. Now I had told you earlier that I had disabled the hypothesis generation part, which is here, this particular. Yeah, so it's inside of this hypothesis generate and eval loop. Now once this is done, we'll say starting hypothesis generation interval, and now just let this do the job. Also I will start up the Discord and show you exactly where the hypotheses are being sent. So this is like an optional step. You can either store it in a database or you can send it to a. So yeah, so this is how it looks like. This is like a previous one that was sent on 10th of April, but yeah, we will wait for the hypotheses to get generated, and yeah. Alright, so this is how. So what happens is that under the hood, first we have a query to get all the findings. So the findings basically are the descriptions that I just showed you. So these are the findings of each papers. If you see the query, this query has namespaces. So Fabio is for research paper, DC terms for the metadata, and OBI for the ontologies. So our objective is to fetch all the research papers along with their descriptions, employing a strategic union to handle both direct and nested description lookup seamlessly. So what I showed you just now. Then so this was the hypothesis that we got, and as you can see, it is sent over here already. Now there is a second part, that is the judging part, that will happen soon. Yeah, so this is the judging part of it. So the research here stands for that this hypothesis is first, like all the terms that the hypothesis discusses, they are searched over the internet, and there is a kind of a research that happens, and based on this research the evaluation is given. So right now, as you can see, that the hypothesis for clarity and specificity, it got 14 out of 15. Then for alignment with evidence, it got 13. Then with logical consistency, it got 14. Predictive power, so novelty, it got 18. So the final score for this hypothesis is 87 out of 100. So so this is how, so this is the complete flow of our plugin. um, yeah and this keeps on happening on a loop, and your and all these findings that are there, they are retrieved from the oxygraph. So once you have the findings and the papers, the abstracts for those papers are also gotten, and those abstracts along with the findings are given to the LM as a context. So and then the LLM generates a hypotheses, and so you can actually go ahead and either you can improve the hypothesis generation algorithm, or you can improve the judging algorithm, or you can improve the paper processing. So you can maybe, so right now the papers, so once you process a paper, it gets converted into this format. So something like this, right? So if you want, you can add rich metadata to this NLT, or enhance the ontology relationships, or maybe enhance citations, or add provenance. So that would be great for verifying information, or add statistical data to this. So I mean, the possibilities are endless. And I mean, this is like the whole walkthrough of the plugin, of how it works, all the things that it has. And I mean, if you have any doubts, please post it on the Discord. I'll be happy to answer them.